Good afternoon everyone and welcome to this video. Well, you could be watching this at night, in the morning or even in the eve, but it's afternoon at my place. Well, as you can see on your screen, it's written predicting the output. What does it mean? Well, you'll be given a code snippet which will be written in some programming language like Java, JavaScript, Python, etc. And you would have to predict the output of the given code snippet. So for this, I'll be giving you some tips and a methodology that will help you do this in much more efficient way. So I'd like you to keep a notebook and a pen with you because we'll be doing a lot of calculations now. So let's begin. So over here we have our first code snippet. This is a print statement from Java. And inside these parentheses, as you can see, I've written the words HELLO, hello. And these are enclosed in double quotes. This indicates that this is a string. So the output will come as it is. That is hello. So this was quite obvious, but let's see how can we modify it. So now we have this print statement and it has an operation going on itself, that is 1 plus 2. So it's quite simple math. So we can say that the output is going to be 3. Unlike the previous one, we had to do some maths over here. So let's move on. Well, we have a print statement from our previous example here. But there's something going on this time. If you look closely, this 2 now has double quotes. What does that indicate? Well, that means that this 2 is now a string. A string is basically a text, and this one is without any double quotes. So that means it is still a number. So what does that mean? We are adding a number with a text? Well, yes. Well, now if we talk about those jokes that 1 plus 1 is 11, so in this example 1 plus 2 is 12. Why so? Because since 2 does not have a numerical value, the interpreter or the compiler will combine it together into a string. That is, the output will now be 1 and 2. That is, this 1 was dynamically converted into a string and then added to this 2. And thus the answer was 12. Okay, so this was a bit tricky one, but let's move ahead now. Well, so over here we now have a variable with us, that is n. So this is the data type int, which means that n will contain a numerical value. So this is a variable n which contains the value 2. And this is a mere print statement which has the letter n written in. Well, let's look closely. Does it have any double quotes over it? No. So that means it's not a string. So what is this n? Is it declared in our program somewhere? Yes, it's a variable. So that means this print statement is going to print the value which was stored in n. So that is 2. So the output of this code will be 2. So let's move on to the next example. So over here, if you see closely, we now have 3 lines of code. The first one is where the variable n is getting declared and initialized with the value 2 plus 2. And if you look closely, there are no double quotes. That means this is no more a string, or it is not a string. And the value of this will be the addition of these two numbers, which is going to be 4. So the value of n is 4 over here. Then we have this print statement, which is printing the value of n. So over here, the value of n is supposed to be 4. But here comes a tricky question. On the next line, we turn the value of n into 0. So what will be the output of this code? Will it be 4 or 0? In this case, you must remember the flow of control. What does that mean? Well, if you talk about an interpreter or a compiler, which translates your code into binary form, it runs in a specific manner, that is from top to bottom. So what does that mean? So in top to bottom approach, the first line is executed, then the second one and the third one. That means it will go like a waterfall from top and then to bottom. So in this, the first line is n. So n is declared, then the value of 4, that is 2 plus 2, initialized. And after that we have the second, that is print statement. So the print statement will now be executed. So in the print statement, at this current instant, the value of n in the print statement was 4. So that's why this print statement will print the value 4, and then the third statement will run, and that is where we turn the n into a 0. Well, do you think that this will have any effect on this statement? Well, no. Why? Because this second statement, that is print statement, it's already executed by the interpreter or the compiler, because we are following a top to bottom approach. So in accordance with that, this line is already executed, and because of that, the effect of this line will not really affect our output, and because of that our output is 4. Well, now we have two variables. So as of now, whatever you have learned, I hope you can apply it now. So I want you to tell me the output of this code. Please pause this video if you need to think for a while. Well, so let me tell you the answer now. So first, this line will be executed following the flow of control, and the answer to this will be n equals 2 plus 2. So we did last time as well, and over here it is 4. So after that, then there is m equals 3 plus 4. So 3 plus 4 is 7. And then inside this print statement, which is the last line to be executed, we have n plus m. So the value of n is 4, the value of m is 7. So 4 plus 7 is 11. So the output of this program is going to be 11. Well, now we have our same example from our previous code snippet, but it's slightly complicated now because we have added these mathematical functions. So let's use the top to bottom approach and try to solve this. So first is int m equals mat.max 2 and 3. So what does that mean? So mat.max is a function that gives the maximum value out of the given two arguments. So here the two arguments are 2 and 3 because they are inside these parentheses and separated by a comma. So the value that n should possess is 3, and in case of m it is mat.min. So mat.min is a function in Java or even in JavaScript that will return the minimum value of the given two arguments. Over here it's 54 and 23. So the minimum value is 23. So the value of m is 23. I'll write that properly. So the answer to this is system.out.println n plus m. So n is 3 plus m is 23, so the output is 26. So now these were quite simple examples. From here, let's make things a bit complicated. Well, what do we have here now? There are 4 lines of code now, and we must remember our top to bottom approach. So in accordance with that, let's try to find the answer. So int n equals mat.max. So even we did this even in the previous example. So mat.max. So the answer for this should be 31 because it's the maximum value out of 31 and 23. So we know n is 31. So let's look at this confusing line now. N plus plus. So this is a postfix operator. So what difference will it have? So for this instant, what it will do is it will increment the value of 31 the next time it will be called. Means over here the value of n will remain as 31, but the next time it will be called it will be 32. Okay, so let's look at int m equals mat.min. So over here we have used n. So here comes the complicated part. What will be the value of n? Well, because of this postfix operator, the value of n plus plus will now be 32. You may think, why not 33? Because there's already this another postfix operator over here, or the increment operator. The thing is that this will have effect on n the next time n will be called, that is on the next line, here n is getting called, so the effect of this plus plus will be seen in this n, not over here. So the value of m mat.min 32 and 23 will be 23. Okay, so over here now, that is our print statement. So n plus m, so the value of n, it is now 33 and m is 23 as we have already found. Why did n came 33? Well, let me tell you that n over here in the first line, it was 31 because we have to find the maximum value out of 23 and 31, so we got 31. Then on the next line we are incrementing n but with a postfix operator. So the value of n will increase by 1, but it will only increase after the execution of that whole line has taken place. So after this line is executed, the value of n will increase. So for this instant, when this line was getting executed, the value of n was 31. And after that, on the next line, where m is being declared, and it is initialized with the value between n plus plus and 23. Now here we have called n again. So the value of n from 31, it will increment to 32. And then we again have this postfix operator. So the value of n will increase the next time it is called. So for this instant, it will remain 32. So out of 32 and 23, the value of m will be 23. And in the print statement where we call n for the third time in our program, here the n will be 33 because over here in the previous line you can see you have done n plus plus, so the effect of that plus plus will now be seen in this n. So it is 33 and m is 23, so 33 and 23 should be 56. So the output of this program was 56. Well, now these were just some simple math calculations. Let's add some conditions in it now. So here is our conditional statement. Why are conditional statements so famous or so popular? Because conditional statements and loops together, they have the ability to break the flow of control. Let me show you how in this example. So following our top to bottom approach, the first line that we have, n equals mat.max 2331. We have been using the same line since last two examples, so I'll directly write the answer is 31. And for like, as the code snippet will get bigger, you will have lots of variables to deal with and lots of operations. That's why I have this pro tip that you write the name of the variable on top or anywhere convenient. I'll write it on top, and you write the value that it possesses. So 31 will keep changing this value as the program goes ahead. And then we have this variable m. So let's see the value of m. So m is n minus minus. So minus minus is a decrement operator, but we must remember its position. It is in a postfix position. So in that case, that tells us that the value of n will increase after this entire line is executed, or simply it's the effect of this decrement will be seen in the next time the value of n is called, so which is over here. So here n minus minus, this will make m equal to 31. The value will not decrease until the entire line is executed. And since the line is already executed, m will take the value of 31. And after that, the value of n will now turn into 30. Okay, so let's move on to our if condition. So if n is greater than 31. So as we can see, because of this n minus minus, n has now turned into 30. So is 30 greater than 31? No, it is not. So that's why this line will not execute. So you may see here that conditional statement actually broke our flow of control. Instead of going to the next line, we are now directly moving on to the fourth line of the program. The third line literally got omitted. So our fourth line is else. So inside else we have yet another postfix operator. So over here, the value of n will remain as 30 because it's a postfix operator. The value will increase later on in the program. And here is our last print statement. Here, the value of n will be 31 because as you can see, because of this postfix operator, the value of n got edited and it turned into 31 again. So 31 plus this m is already 31 as we have done in our first line. So 31 plus 31 would be 62. So the output of this program was 62. So this was an example with a conditional statement, how the things would go. So that's why what I wanted to explain you here was that you must keep a track of the values that the variables contain. Somewhere good, like I did it on top because I had a lot of space. You could have done it on left side or right side. That's your choice now. So let's move on to the next example. So over here we have our first loop statement. And as I previously said, it is capable of breaking the flow of control. Well, let us first start with our top to bottom approach. So here our first line is n equals mat.min mn6. So I finally changed that line. So the value of n should be equal to 3 because 3 is less than 6 and that's the minimum value available. So I'll write here 3. Then we have an m. So this m should be equal to, now look closely, it is a decrement operator but it is in a prefix position. So does it make a difference if it's in prefix position? Of course it does. Since it's in a prefix position, the action will take place before the execution of this entire line. So this prefix operator will make n to right at the moment it is called. It won't work like the postfix operator. So the value of m will be 2. It got changed in that right instant instead of carrying forward the operation. So then we have this for loop. Well, now let me give you some tips over here. So since the beginning we have been following this top to bottom approach. But to deal with loops, I will tell you that instead of following the top to bottom approach, follow the left to right approach. How? That's what we are going to see now. So now I'm going to tell you about this execution table. It's not actually called an execution table, but just to explain you all, this will make these two lines, and then inside that this is 1. So what does this 1 indicate? That means the first execution. A loop iterates until the given statement is true, which is this one in this case. So as long as I less than is equal to m is true, this loop will keep on going. And that's why we're going to make this table so that we can keep track of everything that happens in this loop. So let us try using it now. So the first thing is int I equals 1. Okay, so our loop starts with the variable I and its value is 1. So I'll write that. Then we have I less than equal to m. So that's a true false condition, a boolean condition. So in this expression, I less than equal to m. So what's the value of I here? Well, as we know, it's 1. As we have already found it and declared it in the first instance itself, it's 1. So value of I is 1. And m we have found that it is 2. So I less than equal to 2? Yes, it's true. That means this loop will execute. Then it will move on to this I plus plus. Now remember, this is a postfix operator. Its effect will not take place until I is called once again after this statement. That is in the next iteration. So in this case, I will remain as 1. And since we also have m here, but its value is not changing, we won't mention n. So then we have plus plus n. This is a prefix increment operator. So the value will increment before the execution of the statement. Well, so the value of n over here, well, it was because of this statement here, the value of n had turned into 2. So I'll write here 2. So because of this increment again, now it will turn into 3. Okay, so I'll mention this in this table now. N is equal to 3. Okay, so now we'll move on to the second iteration. And over here, the will move back onto the top. Now you can see how this left to right approach to this loop has changed the entire flow of control. We are now back onto the top. So I is now, since we have used this postfix operator, I is being called again. So I will now be is equal to 2. And then 2 is less than equal to 2. Yes, that's true. So that means this loop will execute. So the value of n will increment here, and this eventually will come in between, but we'll not look at this right now. Plus plus n, this will make n into 4, because it was 3 in the previous execution. So it will turn into 4. So I'll write it here. If you want, you can avoid writing this thing over here, this on top over. If you want, you can avoid changing it here, but I'm doing it for my convenience. So now let's move on to the next iteration. So I'll expand this. So now this is our third iteration. So over here, now because of this, the I will turn into equals to 3. But wait, now let's look at this condition. The value of m is 2. So this is 2, and I is now 3. So is 3 less than or equal to 2? Of course not. So this condition is false. So in that case, this loop will now stop executing. So now here's our system.out.println n plus m. So what's the value of n that we have got? Well, if we look at our execution table over here, n is equal to 4. So now we know the value of n. So I'll just write here 4. So 4 plus m is our 2. So 4 plus 2 is 6. So the output should be 6. So now you know that in case of loops, you have to make an execution table and follow a left to right approach to solve it. Well, let's look at our next example, which will be a slightly more complicated, and I want you to solve it for me. So over here is the hardest snippet of the entire video. Well, this is the combination of all the snippets that you have seen so far. So I want you to solve it first. So you should pause the video here and try to solve it on your own. Use your notebook which you had brought in the first minute of this video. I'd wait here for a few seconds. You can pause the video in the while. Well, I hope you have tried to solve it and you have gotten at least to some answer. Well, then let's try to solve it on our own. We'll first start with the top to bottom approach. So in that case, we have this first statement int n equals mat.max, mat.min 79, 6. So for this one, we'll first need to know what is mat.min 7 and 9, because it's inside mat.max and we need that value to know which is the maximum value. Will it be 7 or 9? So mat.min 7 and 9. So the minimum value that we get here is 7. So this 7 that we have got, out of this 7 and 6, which is the maximum value because it is mat.max. So we get the answer as 7. So the value of n is 7. So I'll write that on top so that I don't lose track of where is it. So n is equal to 7. I'll write that properly. It's such a big 7. Okay. Okay. So for m, the next line is for variable m. It is mat.min minus minus n and n minus minus. So This is a combination of prefix and postfix both. So let's see. First one is a prefix operator. So that means the value 7 will get turned into 6 right at that instant. And on the next one it is n minus minus. So that means that next time the n variable is called somewhere, its value will decrease, or we can say we'll see the decreased value. So n minus minus, so over here it will be 6. So for the value of m that we get should be equal to 6. I'll write that on top as well, because anyway both the numbers are same, so eventually we'll end up on getting 6. So, and since we know that this decrement operator, which is on postfix position, will eventually decrease the value of n, I'm going to write the reduced value here itself. So first we got n to 6, and because of this operator we'll now turn it into 5. Why 5? Because it turned into 6 because of this prefix operator first, and then it turned into 5 because of this postfix operator. It all happened in the same line. Well, now let's move on to our loop. So let us make an execution table, this line and this line, and the table is done. So for the first iteration, let us see the loop. So we have an I declared here, which is initialized with the value of 1. Then we have I less than equal to m minus minus, another postfix operator here. So the value of m will change eventually in every iteration. So let us write those values. So we have I, which is equal to 1. Then we have m minus minus. So this is postfix operator. So for this first iteration, m is going to remain as 6. However, in the next one, it will turn into 5. But let's look at this iteration only. And this is the postfix operator for increment of I. It's going to happen in the next iteration. We'll see its result. Then we have this inside line plus plus n. So this is a prefix operator. So the value of n will increase right at that instant. So for over here, n turned into 6. Now let's see the second iteration. Here the value of I will be 2 because of the increment operator which is here. So I turned into 2. Then m. So m will turn into 5 now because of the decrement operator. I'll write that properly. M equals 5. Then we have n, its value is increasing, so I'll write n is equal to 7. Then let's move on to the next iteration. Now I will turn into 3. And then we have I less than equal to m minus minus, so m is equal to 4. So that is a true condition, so the loop is still executing. And then we have plus plus n, so it will turn n into 8. Now we'll extend this table. So in the fourth iteration we have I, which is equal to 4. Then we have m, whose value is decreasing, so m is equal to 3. But wait a second, if I is 4 and m is 3, so is 4 less than or equal to 3? No, so that means the condition is false. So this loop for fourth iteration, it won't run. So it ran only since from the first iteration till the third one. So now we can move to our last statement, that is a print statement, and it has n plus m like all other examples. So the value of n that we have got according to our table is 8. So I'll write here 8. But now here comes the tricky question. What will be the value of m? You may say that it is 3. Why? Because it has decreased in the loop. But you're forgetting that this is a postfix operator over here. This is a postfix operator. So when it was executed, the postfix operator will show its effect the next time the value will be called. So in that case, the value of m here should be 2. I hope you're understanding this, because in each iteration the value was decreasing by 1. So over here it was 6, it was 5, it was 4, it was 3. And the next time it was called, it turned into 2, because we are using a postfix operator and not a prefix operator. If we would have been using a prefix operator, then in the first iteration itself m would have been 5, but it is 6 because we are using a postfix operator. So keeping that in mind, we get 8 plus 2, which is 10. So that was the hardest question that we had. Now let's see another example where we don't use a for loop. So over here we have a while loop. This question was actually asked by my friend and he asked me to do it here, so here it is. So let us start with a top to bottom approach. Well, we can see in the first line itself all the variables are declared, so I won't be mentioning the values again. So let's move on to the next line, which is itself a loop. Okay, so let us make an execution table for the loop. So one line, second line, and the table is done. So for the first execution, let us see what is there in the loop. So we have I plus plus I less than 6. So this is a prefix operator before I. So that means the value of I will increase before the execution of this entire statement. So I is equal to 3. Okay, so is 3 less than 6? Of course, yes. So then we have this k into equals I. Look closely, it is k into equals I. What does that mean? Well, this is a shorthand expression for a longer expression actually. So it is k equals k into I. So this expression is written in a shorthand form like this way. A lot of programmers do that, but it does not make a difference since it's just the difference of 1k. Well, so the k's value is 1, so it is 1 into I is 3, just we have found that. So I is 3. So value of k is also 3. So k equals 3. Now let's see the second iteration. In the second iteration, we have plus plus I first of all. So I is equal to 4. Then we have k. So k's value we got in the previous iteration as 3. So it is 3 into I is 4. So we get k is equal to 12 because 3 4s is 12. Simple math. Then moving on to the next iteration, we see plus plus I. Then I'll just increase the table. Okay. In the third iteration, we will see that I is equal to 5. So we get I as 5. Then we get k. So k was 12. So 12 into I we got as 5. 12 5s are 60. So k is equal to 60. So for the fourth iteration, we'll get I plus plus. So i's value will increment and we'll get 6. But over here, if you notice, 6 less than 6. This is a false statement. So that is why this loop will now stop executing. So that's the end of this loop. And then for this system.out.println, we get k. So the k's value we have got as 60. So the output of this code is 60. Well, that is it with this video. It has been quite a long video now. Well, we have already spent 30 to 34 minutes on understanding how to predict the output. I hope you have learned something new and I was able to help you out with your problems. And if I tell you, this video was actually requested by my friend. So if you have any other requests, feel free to ask me. Thank you.